Is our universe a hologram? Physicists debate famous idea. The universe has been a subject of fascination and study for humanity for thousands of years. As our understanding of the universe has developed, so too have our theories about its nature. One such theory, the holographic principle, suggests that the universe as we know it may be a holographic projection of a two-dimensional reality. This idea has sparked intense debate among physicists, with some finding it intriguing and others deeply skeptical. In this article, we will explore the holographic principle in depth, examining the theoretical evidence supporting it, the experimental observations that have been made, and the criticisms it has faced. We will also consider the implications of a holographic universe for our understanding of physics, cosmology, and the nature of reality itself. The holographic principle, understanding the basics. Introduction to the holographic principle. The holographic principle is a theory that suggests all the information in the universe can be represented as a hologram. According to this theory, our three-dimensional universe is nothing but a projection of a two-dimensional boundary. The origins of the holographic principle. The origins of the holographic principle can be traced back to the work of physicist Jacob Bekenstein in the 1970s. The principle was further developed by renowned physicist Stephen Hawking, who proposed that black holes could be seen as a type of hologram. Theoretical evidence supporting the holographic principle. Black holes and entropy, theoretical underpinnings of the holographic principle. The holographic principle is based on the concept of entropy, the measure of disorder in a system. Physicists have discovered that the entropy of a black hole is proportional to its surface area, providing evidence that a two-dimensional surface can hold all the information about a three-dimensional object. String theory and the holographic principle. String theory, also known as the theory of everything, suggests that the universe is made up of tiny strings that vibrate in different ways. This theory also supports the holographic principle, as it suggests that our universe is actually a holographic projection of a lower-dimensional reality. Experimentation and observation, evidence for a holographic universe. The search for gravitational waves. In 2015, scientists detected gravitational waves for the first time, which provided further evidence for the holographic principle. The ripples in spacetime detected by the Laser Interferometer Gravitational Wave Observatory, LIGO, could be seen as a projection of a two-dimensional surface. The AD/CFT correspondence. The AD/CFT correspondence is a principle that relates two different theories of physics, anti-de Sitter space, ADS, and conformal field theory, CFT. This principle supports the holographic principle, as it suggests that the information in a higher-dimensional universe can be represented as a lower-dimensional quantum field theory. Quantum entanglement and the holographic principle. Quantum entanglement, the phenomenon where two particles can be linked in such a way that they are always correlated, also provides evidence for the holographic principle. This is because quantum entanglement seems to be a fundamental feature of our universe, and suggests that information is not stored in individual particles, but rather in the connections between them. Criticisms and objections to the holographic principle. Philosophical objections to the holographic principle. Some philosophers and scientists have objected to the holographic principle on philosophical grounds, arguing that it undermines the reality of our physical world and reduces it to an illusion. Scientific criticisms of the holographic principle. Others have raised scientific objections to the holographic principle, pointing out that it is difficult to test, and that some of the assumptions made in the theory may not be accurate. However, many scientists continue to explore this fascinating idea, hoping to gain a better understanding of the nature of our universe. The implications of a holographic universe, what it means for physics and beyond. The idea that our universe might be a hologram is not just a wild science fiction concept, it has been discussed and debated by physicists for decades. The holographic principle proposes that our three-dimensional world is a projection of a two-dimensional surface, much like how a hologram is created from a two-dimensional pattern. While this idea might seem far-fetched, it has implications that could revolutionize our understanding of physics, cosmology, and even philosophy. Implications for theoretical physics. The holographic principle challenges the traditional understanding of space and time. It suggests that the universe could be fundamentally different from what we think, and our laws of physics may need to be redefined. The principle implies that gravity, one of the four fundamental forces of nature, is not actually a force but a consequence of the universe's geometry. This could lead to a better understanding of the long-sought-after theory of everything, which aims to unify all the fundamental forces of nature. Implications for cosmology and astrophysics. The holographic principle could also have implications for cosmology and astrophysics. If our universe is actually a hologram, it could explain certain puzzling observations, such as the uniformity of the cosmic microwave background radiation. It could also provide a new perspective on black holes, which are considered to be the ultimate test of the laws of physics. The principle suggests that black holes are not necessarily the end of the line, and their information might be preserved on the holographic boundary. Implications for philosophy and the nature of reality. The holographic principle raises profound philosophical questions about the nature of reality. It challenges the traditional idea that the world we perceive with our senses is the only reality. If our universe is a projection, what is the true nature of reality? Is there a higher dimensional world beyond our perception? These questions have intrigued philosophers for centuries, and the holographic principle might provide a new angle to approach them. In conclusion, the holographic principle might seem like a bizarre idea, but it has implications that could transform our understanding of the universe, from the fundamental laws of physics to the nature of our existence. While it is still a speculative theory, it has inspired further research and could lead to revolutionary insights that we have yet to imagine. The holographic principle remains a subject of intense debate and discussion among physicists and scientists. While some have found it to be a compelling explanation for the nature of the universe, others remain skeptical. Regardless of its ultimate validity, however, the holographic principle represents an important avenue for exploration and inquiry, and may ultimately shed new light on the deepest mysteries of our universe. Thanks for watching.